All right, let's go through and solve some rational equations. So let's say I have this particular example that's right there in front of us. Well, I want to get rid of those denominators. I don't want to deal with trying to find common denominators and then multiply numerator denominator and then go through and add them all together. Nah. Let's figure out what the least common denominator would be in this case. So I want to figure out the least common denominator. In order for me to do that, I got to go through and actually factor these things. Well, this is a difference of two squares. X squared is a perfect square. 25 is a perfect square. So when I factor these denominators, I'm going to get x plus 5 times x minus 5. So that's what that simplifies to. And the nice thing is this one is exactly the same. So it makes life a little easier going. Then I have my x minus 5 here. So I look here and I say, okay, what does this fraction have as its denominator? Well, I've got an x plus 5, and I have an x minus 5. Move to the next fraction. What does this denominator have that this one did not? Well, they're exactly the same. So I don't have anything to add to my least common denominator. Now I look at this denominator. What does this denominator have that this one did not? Nothing. X minus 5 is already contained there. So I don't have to do anything else. This is my least common denominator. I want to get rid of all denominators. So let's take and multiply every single fraction here by x plus 5 and x minus 5. So I'm going to do that. It's going to take me a couple seconds here just to write each of these. But I'm going to multiply every single term by x plus 5 and x minus 5. All right. So now, whatever I multiply, and if I divide by the same thing, they simplify to 1. So the only thing I'm left with over here is 3. So 3 is equal to. Then that's gone, and that's gone, which is the entire intent of going through and multiplying everything by the least common denominator. Here I've got an x minus 5 that goes away, and this one goes away. So the things that are left, I still have the 2 left, and I still have the x plus 5 left. All right, so now let's distribute that to 3 is equal to 7 plus 2x plus 10. Let's clean up that one side. So I get 3 is equal to 17 plus 2x. Subtract 17 from both sides, so I'm going to get negative 14 is equal to 2x, which then means, and I'm just going to carry it over here because I don't have a lot of room, I'm going to get that x is equal to a negative 7. Now I want to check. All right, so I take that negative 7, I'll substitute it back in here. Do I get a 0 in the denominator? No. At no spot do I get a 0 in the denominator. So my answer is actually x equals 7. Scroll down to another example that we have here. All right, so if I continue with this example, I got to take a look at the common denominator. Over here, I don't have any denominator, so that makes life a lot easier. And these two denominators are exactly the same. So therefore, my least common denominator here is going to equal 3x plus 2. So I'm going to come back to my work over here, and I'm going to multiply everything by 3x plus 2. All right, so again, the whole reason for going through and doing this is so I do not have to deal with denominators. Now over here on the left side of the equation, I've got 1 times 3x plus 2. That's nice. It's just going to give me 3x plus 2. Gone. See ya. Have a nice day. 2 is what's left. That's gone. That's gone. Again, the whole intention of doing this. And then we get 3x plus 2 is equal to, let's just combine this side, 8. Subtract 2 from both sides. 3x is equal to 6. Divide both sides by 3, and I get that x equals 2. Got to double check. I got to make sure that I didn't get a value here that will make my denominators be 0. So I get 3 times 2 is going to be 6, plus 2 more, it's going to be 8. Nope, I don't have to worry about anything here. My answer is that x is equal to 2. All right, there's just 2 examples of how to go through and solve rational equations. Hopefully it was helpful.